Well, good afternoon. Uh, This is Comp 422 and Comp 620, Information Privacy and Security. Today, we're going to talk about web security. I got an email today from University IT telling me that this is National Cybersecurity Awareness Month. I think you may have did you get the same email? Okay. You may be interested in some of the events. They may be of value to read. Tomorrow, Thursday, October 5th at noon is the deadline for your second chance doing the number-based conversion quiz. Remember that this thing is timed. You have to do it fast to get a good grade. Your score is the percent correct minus subtracting the seconds over the time limit. A number of students have done it. They go, oh, I got 100% correct, but it took them 3 minutes to do it. That's not going to cut it. You have to get it fast. Your limit depends on which class you're in. If you are a 422 undergrad, 90 seconds. If you are a master's student, 120 seconds. And if you're a post-baccalaureate cybersecurity student, that is the post-baccalaureate cybersecurity certificate, not students in the undergrad program looking for cybersecurity certificate, separate. Okay. Remember, you got to do it fast. And the maximum score you can get is 85. So if you get over 85, I'll just trim it back down to 85. Here's the schedule coming up. Today, we're talking about network capture and other network security things. That's today. Next Monday. Monday is fall break. Don't come to class. All classes are suspended. Fall break. Enjoy yourself. And then next Wednesday, we'll have another class more on web stuff. And then again, after that, more web security stuff. And then 2 weeks from today, a second exam. That's important because the Monday after that is the last class before the last chance to drop courses. So if you're still in the class, Wednesday, that would be 1, 2, 3 weeks from now, then you're in the class. There's no hope for you. Okay. Anybody have any questions about the schedule topics? All right, then let's talk about the web. We're going to talk a little bit about how the web works because an awful lot of the security things that occur these days are web-oriented. Many of the attacks are based on the web. There is a course, Comp 725, Web Security, and we're not going to cover all the stuff that they cover, but we'll do a brief overview of the web and the major security problems in web applications. All right. Web has been around for a long time. The web is basically two big pieces. There's a hypertext transfer protocol, HTTP, which is used for sending files back and forth. It's an application layer protocol. If you remember last lecture, it's top layer protocol. It's used for HTML. It's also used for sending other types of information. And then there's the hypertext markup language, which is a way to display the information on the screen, which includes links where you can click on it and go to another page. That was all developed in 1989 by Tim Berners-Lee, now Sir Tim Berners-Lee. I might point out I read way back in the 70s about the idea of hypertext markup language. Tim Berners-Lee wasn't the first one to think of it. I read about it way back then, but he put it all together and made it useful. All right, let's take a look at your standard URL, Universal Resource Locator. It's got a bunch of parts that are pretty simple. The first part of it is the, scheme or the protocol, what you're going to use. HTTP or HTTPS are very common. Sometimes you'll see file, and that's not coming over the network at all. It's just coming from a file on your computer. There are others, FTP. Then : the IP name of the server, followed by a path. Optionally, there may be a port in there, usually :80 would be the default. You don't have to specify it. If you don't specify it, assume it's port 80. And then a path, which is just like you might find in your files. It's the path on the web server as to where to find the file you want. And then there's the file name, followed by more information if you want. There can be parameters. Some websites are going to send parameters to a program. Here you're executing a program, and then we're sending these parameters to the program. We'll talk about that shortly. Or fragment, the pound sign, the hash, the pound, that indicates where in the web page you want to be. Okay. Now, when you type this in your browser and you hit enter and it sends it over, it's going to send a HTTP request off to the server. It's written in ASCII, you can read it. In fact, if you go into a Telnet program, connect to your favorite website, you can type this in, press enter, and it will work. It will give you back the HTML. Now, it'll display as raw HTML because Telnet doesn't do anything for displaying it, but it's just ASCII. You can type it in yourself. And all the lines are ended by a return, which is a character return line feed. And then at the very end of all the options and stuff, there's 2 character return line feeds. This is the end. More stuff may or may not follow. Okay, there's a method. A method is what kind of function, what do you want this to do? And there's a file name. It's going to get something. And there's options. Also, the HTTP version you'd like. All right, here's an example. We're going to do a get. Get is very common. You want to get a page from the server. There is the name of the page you want to get, mypage.html. Host. Host is not really an option. It's a required option, if that makes any sense. Once upon a time, it was optional, but now it's required. It appears with the options. And, all these things, but they're case insensitive. But host, and then your website. The reason host ends up there is required. So there's a lot of systems, particularly your cloud-based web servers, are serving many websites. They hire their services out for many different websites. You have to tell them what website that you want to go to. Oh, okay. There are your popular HTTP methods. Get is the one that you most normally use to get a web page. Head just gets you the information without the contents of the web page. That's sometimes useful for things. Post means I want to send information to the server. If you have a form, you're filling out the form, you press submit, it will do a post and send the information. And then there's others. Delete the file on the server, and several things for managing the website. Now, when you send that off, the server will then send something back. Again, it's an ASCII text, comes back to you, starts with the version of HTTP that it's using. I have 1.1 here. I think we're on a much later version now, but 1.1 works. A status code, go over some of those. And then a reason. The reason is optional. The status code is just a number for computers. The reason is in case a human happens to see it and want to know what's wrong. And then options tell you something about what you're getting, whether it's compressed or any other information about this. And then a blank line, and then the contents of the file. Here's an example. Come back status 200. 200 is the happy status. 200 means it worked. Here comes the information you requested. Okay. And some of the information that's sent is like the date. When did you get this? The server tells you what kind of server it's coming from. I'm not sure why you need to know that. It's kind of interesting if you're trying to hack into the system to know what kind of server you have. Last modified, that's an important. The last modified tells you when this file was last updated. There is a feature in the web to say, get this if it's been modified since this date. In other words, I have this, got it before, I got the version on 17 November 2020, and give it back to me if there's a newer version. If not, just let me know that I have the latest version, which saves sending it back and forth. And then how long is it? Other things. What type of format is it? Then there would be doesn't show cover, there's a blank line in here. And then in this case, the HTML that you're sending. Server statuses are varied. 200 is the happy message. There are 300, that's a redirection saying it's moved. There's moved permanently, it's no longer here. I think with that status, it will tell you where it has moved to. 400 means something went wrong. It blames it on the client. The most common one you all say 404, file not found. That means you've asked for something that's not there. There's also several other forbidden and unauthorized. Forbidden means you are not allowed to get here. Unauthorized, I think, means about the same thing, although there is a subtle difference between the two. 402 means you have to pay for this information, right? Giving it away for free. And I like the 410, gone. It was here, but now it's not. And then there's the 500 internal server error. 500 errors are pretty basic. That means something went wrong. Doesn't tell you what went wrong. I happen to know, having generated many more 500 errors than I want to, that if you write a PHP program on the server and the PHP program gets an error, or you're accessing an SQL database and it gets an error, then it will return a 500 status. 500 internal server error. Something went wrong. Yes, question? Yes, Ajax using HTTP. Okay, so let's see if you're paying attention. Let's try our first poll of the day. I guess we'll use the generic polls online because I don't have good ones. Okay. Oh, we have a split. Undecided. All right. The online people thought it was ASCII. People were unsure in class. It is ASCII. Just if you use the Internet Protocol or TCP, those send packets whose headers are binary values. That you how many bits are in this field, how many bits are in that field. Whereas HTTP, it's an application layer protocol. It just types the things. You can type it yourself if you wanted. So yes, sir. Unfortunately, it's not in the textbook. So yes, the question about where do you find this material in the textbook? Alas, you do not. Textbook does. Most of the web stuff, I'm not sure why. I think the textbook got a little out of date, or else they went one direction, and I try to be a little bit more practical. An awful lot of the problems you find in security are on web-based applications, so I think it's important to cover that. Oh. All right, moving on. Web pages typically have multiple files in them. You'll see the text in the background, and then there'll be images, that sort of stuff. The images are all come from image files, and they're downloaded separately. Every file comes one at a time, if the file is different. Again, this is where the server may say, I've got this picture. Do I have the latest version? And if it comes back and says yes, then you use the old version that you have. If it doesn't, it'll send you a new one. But it asks for each file individually. So if you see pictures, and frequently, if you're on a website that has lots of pictures, because of the slow server, the pictures will come in piece at a time, and you'll see them popping up. You get the background, and then the pictures come up. Some websites, the developer of the text specified how big that picture is going to be. Other times, they just said, put a picture here, and it is whatever it is. So everything gets juggled around as the picture comes in. The system figures out what size it is and tries to fit it into the text. So here's a basic thing. We have a socket is a network connection. It's not a physical thing. So creates a socket, connects to port 80 on the server, sends a GET request to the server. And the server sends back the header describing it and the contents of the file. Good enough. So you sent the get, you got back what you wanted. Then your browser looks at the HTML that it got, goes through it and finds image places where pictures are supposed to be stored, and it tells the browser where that file should come from. Typically, it comes from the same server, although it does not have to. It can come from other servers any place on the web. In that case, the browser will then do another GET request asking for the image file. It will then be sent the image file, what the header is before, and the contents of the graphics file, which is just a bunch of unreadable text, because graphics are typically JPEG or PNG or any other formats we talked about in their binary values, and it will display those in the appropriate place. So it's 2 steps: go out and get the background, and then go out and get the image. Actually, you have to get the images individually. So if you have 10 pictures in your web page, it has to go out 10 times and get those pictures. We talked about transport layer security a little bit before. That's what puts the S in HTTPS, the secure. It's a hybrid security level. Yeah, okay, we'll talk about it again. It uses port 443. Now, normally, if you just type in HTTP, it goes to port 80. You type in HTTPS, it goes to port 443. A lot of servers, if you go to one, it will ship you to the other if it needs to. When it goes to port 443, during the initialization of the connection, it will establish an encrypted connection, which I'll talk about in just a minute. But again, I mentioned that move permanently. You go to port 80 to get a web page, and now it's running, and on the secure version, it will tell you it's no longer here. It's on maybe on the same server. It's just on now on port 443 because it's now secure. There are various security layers. There used to be something called secure socket layer. That was very popular, created in 1995, and then deprecated 20 years later when TLS, transport layer security, came out, and it was better than secure socket layers. Although, note that the definition of it says there's not all that dramatically different. It's kind of the same. They just upgraded it, finally got a version that they liked. New systems should not use secure socket layers. They should use the transport layer security, TLS. Now, when a system wants to connect to a server, when your laptop wants to connect to a server to get a web page, there are several messages that go back and forth down at the transport layer. It will send a connection request called an SYN or a SYN command from the client to the server saying, I want to connect. The server will then send back a response saying, okay, I got that, you can connect. And then the client will send back a message to the server saying, I got your message, and now we're all set to go. There is a bunch of this. Yes, I got it. Yes, I got it. In fact, how do you know that the server got the ActiSend? Well, that's a problem. Okay, when it wants to connect, again, it's hybrid encryption. It starts with RSA and then moves to AES. It starts with asymmetric using certificates and then goes to symmetric. After it tells what you want to do it, they find a hash function. There's other options. We're going to do any compression, which kind of hash functions, what kind of a security algorithm, encryption algorithm you're going to use. It then picks a random number because it sequences all the packets. But they don't all start at 1. They start at a random number. That's also security because you don't know where it's going to start. It also helps because then you get packets. Packets don't always start when they don't overlap as lightly. If one connection gets mixed up with another connection, you're not likely to notice, because if you randomly pick to start, well, you're someplace between 0 and 3 billion, or 2 billion. So you don't know where it is, and likely they're going to overlap. Here's a picture. Okay. Client, your laptop, is going to connect to the server, sends that SYN connects. The system says, oh, I got it, and sends back a request. sends back an acknowledgement, says, okay, send some parameters to it. We won't go into it this class. That's part of TCP. Then, because we're doing HTTPS, it sends a request or acknowledgement back over the server. The server then sends its certificate to the client. And then the client says, okay, we're going to do that. It makes up a key and sends the key back over to the server, encrypted with the server's public key, which it knows because it just got the certificate. Another thing about the certificate contains the name of the server. The client should check and say, is this certificate for where I expect to go? If I went to www.acme.com, is this a certificate from Acme? If it is, fine. If it's not, there may be an issue. Then it sends back a request. Now the server has the AES key that was shared from the client, and they start encrypting everything with the AES key. Now they're going back and forth with the data. So it takes a while. Messages going back and forth, establishing the connection. And as I mentioned, the certificate is part of the authentication of the server. Your client knows that you're connected to the real server, that somebody hasn't intercepted the message and sent you a false response, that you know you've got the right certificate. Certificates have the option of being revoked if the certificate authority believes that that certificate has been compromised. If somebody knows the private key to that certificate who shouldn't know the private key, then you can cancel the certificate. You can tell the certificate authority it should not work anymore. The certificate authority will put it on its revocation list. So when you get a certificate, you also should send a request out to the certificate authority saying, is this still a good certificate? And it'll send back a message saying, yes, it is. Or we'll send back a message, no, it's not, in which case you should not communicate with whoever gave you that certificate. I might notice it's optional to check that. You should do it. System should do it. It's a software item. When you write your software and you get a certificate, check to see if it's still good. And there's all sorts of things you can decide when you are using TLS, whether you are going to use what encryption mode. GCM, we talked about GCM. And secure cookies. We'll talk about cookies on Wednesday next week, since there is no class on Monday. We'll talk about cookies. And there is a flag in one of the cookies that says, always use HTTPS, always use a secure connection. All right, so on the server side, what do we have? Of course, we're doing HTTP to communicate. We're using HTML to show the text on the screen and the pictures. And we're going to use JavaScript or some other script language. JavaScript is the most popular one to run programs in your browser. On the server, we're probably going to run PHP or JavaScript or Java, and possibly SQL if you want a server-side database. SQL isn't required. There's non-SQL databases. Normally, non-SQL databases are used by students who got a bad grade in their SQL class. Okay, you might enter data on a web form. The JavaScript looks at that data, maybe massages it a bit, checks it, and then can send that data back to the server. Has to send it back to the server from which the original web page came from. The server then gets that request back, looks at that data, decides what to do with it, can do some processing, look at the database, check it out. For instance, when you get to the end of the number-based conversion, it will, done 20 questions, it will then send your scores over to the server, which will store it in the database. There are several formats for sending the information back and forth. Some of the most popular ones are JSON and XML. So here is a question about you, not about the class. Let's just try this one. If you've created a web page with HTML, JavaScript, and server-side programming, choose C. All right. There are a number of people who've done a website, a couple more who've done a website with server-side programming, but there's a countable number of students who have not ever generated a website. You ought to do so just for the interest and knowledge of how to do that. It's not that hard. We're not going to assume, we want to go over some of the basics here. As I look at this, I realize if you've never done this, you probably don't know what the domain object model is. Maybe I'll talk about the domain object model a little bit on Wednesday next week. All right, but you see there's a lot of brackets. HTML has lots of these less than greater than type brackets all over the place. And the brackets enclose commands, and then what's outside the brackets is the text. So here we have a quote P, and that starts a paragraph. The end of a paragraph or end of any matching thing, they always start with the keyword and they end with the slash keyword. So here, this one begins with a P, ends with a slash P. Down here, something begins with script and ends with slash script. So here, text mom and apple pie will appear on the screen. There's a parameter here, ID. ID equals thing. Thing is in quotes. It's always got to be in quotes. But that just gives this paragraph an ID. It gives it a name, which is nice because then in the JavaScript, which is a programming language used in HTML, you can then get that paragraph or change that paragraph. Here we're going document. Document is the whole web page. Get element by ID is a function. We pass it the parameter thing, and it says, oh, you mean this one that's got the ID of thing on it. Inner HTML means that's the HTML that is inside this. In this case, the inner HTML will be mom and apple pie. And I'm going to set it to evil and corruption, where the word evil has emphasis and end emphasis before it. So it's going to usually be bold and corruption. So I changed mom and apple pie will be changed to evil and corruption when you execute that. You can change all parts of the HTML that appears on the screen, or just change the whole page if you think necessary. Yes, you have a question?
So for the second thing is the name of the ID?
Yes, in here, so we said get element by ID. That's a way of identifying a part of the web page. The easiest way to do it is to give items you want to change an ID. In this case, they call it thing, which is just an arbitrary name. Thing is just something. And then here I say, I want the ID labeled thing. Yes, so it's going to, and then this is going to change what's inside a thing. In this case, it was mom and apple pie, which is inside the paragraph labeled thing. So we're going to change that. You could change other data about it, but we're going to change what's inside. Now, as you talked about before, SQL injection, a lot of security problems come around when you take untrusted data, data that you got from the user, and then you use it someplace that gets interpreted. And it comes from all over the place, typically from user input, can come from server, databases, cookies. And then you mix that up with text that gets interpreted, and you have all sorts of errors. But basically, many injection attacks occur when you try to put user data in. Let's go over one of the worst ones. Cross-site scripting, usually abbreviated XSS. Cross-site scripting is when you put non-trusted user data, something that the user has entered in, and you put that text into some of the information that will get displayed. Now, frequently, you want to display information the user entered. If the user entered their name, you might want to say, "Hi, Ken," or something about them. And this has been a very prevalent attack. It's out there a lot. Later on in the class, I'll talk about what attacks are most common, but this is a very common attack. It's gone out and gotten Twitter, Facebook, MySpace, almost all the popular social networking sites. Now, most of these social networking sites have a lot of effort into preventing this. It rarely happens anymore, but it has happened. Almost every one of them got hit at least once before they figured out how to protect themselves. Okay, so let's give some examples here. Let's say the web page asks for your name. Fill in the little blank, press the submit key, and it takes your name and puts it in the field. In HTML or JavaScript, you can give a label and give it a value. In this case, the name of the label is user equals Ken. And that will send this off on the request after going out to example.com. I'm going to run the program myapp.php. We're going to give it the user. So the PHP program can say, give me the data with the name user, and it will return KEN. So that goes over to the server. The server then responds, sends back a message, and says, hello, Ken, amongst many other things. But it's taken the data they entered, put the word hello before, put it in the paragraph, appears on the web page that it sends back to you. So fine. You type in your name, the next thing is hello, Ken. How nice. Try to personalize your websites. But what if I didn't enter my name? What if instead I entered bracket, script bracket, alert, parentheses, quote, gotcha, quote, parentheses, semicolon, bracket, slash, script, slash. That's JavaScript. The script says we're starting JavaScript. We're starting script by default JavaScript. The slash ends. What's in the middle there has to be JavaScript. Alert is a pop-up box. An alert box in JavaScript says, open up a pop-up box and put this text in it. And so when you do that, instead of saying, hello, Ken, it will say hello, and then a box will pop up and we'll say, in this case, got you. With the OK button, make box go away. That's benign, doesn't really hurt anything. But it didn't have to be just an alert saying, hello, I got you. It could have been all sorts of other JavaScript to do other things that you might not want done in your computer. Here is more details of what's actually happening underneath. This is an HTML page, starts with HTML, ends with /HTML. We have some script here where we're defining, this is the script. We have a function called showName. And showName simply gets the text from a field called inStuff, gets the value of that, puts it into variable user_in, and then document write says, hello, user_in. That's going to rewrite the document. It's very simple. Down here in the body of the HTML, we have an input field. An input field appears as a little box like you see in all of it. It says this is a type text. And on change, when you change the value in that box, it's going to call the function showName, which means it's going to get what's in that box. And that box is labeled ID inStuff. That's how we know how to get it. I also have some parameters. How much text can you enter? How big is the box? This box, interestingly enough, will allow you to type in 80 characters, even though the box is only 50 characters wide. You normally shouldn't do that. If you want them to enter up to 80 characters, make the box 80 characters wide. Because it'll scroll over. It's annoying to see. And here, most importantly, is a pattern. This is what the input should look like. The input should be composed of letters A through Z, the lowercase letters A through Z, bracket, a plus sign says many of those. There's many, like one or more. That's a protection against bad input. If you type a bracket, it's not going to match the pattern, it's not going to allow it. An HTML5, which is what we're using these days, you can specify how the input should look. I mentioned that was type equals text. It could say type equals number, in which case it only allows you to type in the number. Now it allows you to type a number in any format. It can be 1.25e to the 42 if you want, but it only accepts numbers. You can, in the field, specify how big and how small those numbers are supposed to be. There's a number between 1 and 10, or anything. You don't specify, allows any number, but you can say a number between 1 and 10. You can specify this is a URL or an email address, in which case things that don't look like email addresses won't be allowed. It'll give you an error message. And then for just general text, you can specify a regular expression. Those of you who've taken the theory class and understand what regular expression is, you can specify with great detail exactly what format that input should look like. This is very useful for catching errors that the user might enter. They were supposed to enter an email address and they messed it up. They might catch that and you can tell them, oh, bad format. It's also very useful for slowing down attacks. There are functions in HTML and web and JavaScript to check the validity of things. You can say, match the input against the pattern that was given for this input. Is it good? And it will say yes or no. Check validity is very simple. It just returns true and false. Does the value that you entered match what you said? There's when I said there's a pattern here, it doesn't automatically check the pattern until you ask it to. That's nice because sometimes you have a custom error message that you're going to give the user if it doesn't match. Check it, it'll match, okay. If it doesn't match, you can tell them, oh, fool, you mistyped the email address. There's also report validity, but that one displays an error for you. So if you want the system to display an error for you, you do report validity. If you want to display the error, make the decision yourself, you call it check validity. So here we are, a little bit, same thing with a little bit more error checking in it. So again, we have the pattern down here. We have the show name, which is called get on change. Whenever you change the text in the screen and press enter, it will call on change, or press enter or move out of the box. It will call on change. Goes up there, calls it, gets the data, and then it's going to check the validity, report validity. In this case, we're doing the report, not just check. And if it's okay, great. If it passes the validity test, in this case, if it's just letters, then it will change the document and say hello that. If it's not, though, if it's not just letters, then you get an error message. It says, oh, get my message, which hopefully there's a field in your text called my message, and change it to bad input. So you can tell the user you've got bad input. Now, some people wonder, well, okay, I can type in messages that appear on my, cause things to appear on my screen. I can type in alert, and alert pops on my screen, but it's appearing on my screen. So I'm attacking myself. Well, what good is that? I mean, who cares about attacking yourself? But you can attack others. There's what we call persistent and non-persistent cross-site scripting. Persistent is also called, excuse me, non-persistent may also be referred to as reflective. Non-persistent is what I talked about. It's when you enter JavaScript into a field and it executes that. Basic problem, again, is you are taking user data and putting it into something that gets interpreted, and that causes errors. This is very common. Often, the data that you enter goes to the server then uses that as an input for database query, get your name, gotta go find out stuff about you. You don't want to put bad stuff out there. And of course, it may reply with information. It may go to the server, you've given its name, it replies back and said, hi, your name. But if it wasn't a name, if it was JavaScript, execute JavaScript. So, look at this. Carol knows Bob. Carol knows that Alice uses Bob's website. That got merged together to Bob's site. Okay, yes. Bob's site is Bob's website. Bob's site. So she crafts URL, puts it in an email and says, oh, go out at this. And it will go to Bob's site. We'll search for query puppies. That's going to look for puppies. But additionally, it's going to go to this script source. It's going to get the script from this site. So it's telling the user, okay, go to this website, get the JavaScript and execute it. And that's likely to cause a lot of problem. So, and she puts this in an email, changes what appears, because what appears in the email, you can say, click here, H-E-R-E, and here may be this URL. And so Alice gets it. She likes puppies. She clicks on that and it executes this. What goes down, goes to the evil website, gets the authentication, stealing information, gets that, and sends it back to Carol. Now, Carol has the cookies that Alice uses, and now she can log on as Alice to, say, Amazon or whatever website we're talking about. So that's non-persistent. It's a threat, even though it's just one time, nothing was saved. You put it in an email message that you send, that in this case, Carol sends to Alice. Alice clicks on it, so she's executing that page that has the request to execute JavaScript. In this case, it's JavaScript that's someplace else. You can have all your files come from different places, just like you're downloading pictures, you can download the JavaScript. Okay, then there's persistent or stored cross-site scripting. That's where the information that you typed in gets stored in a file in a database on the server, and then it's displayed later on. The most common version of this is that you type in some information that will then be later displayed on other users' machines. Say you've got some sort of social media site, and you type something in with the brackets, script, and all the other commands, and you store that in, and then that information is then displayed on another user's computer when they go to that website, and they're going to look at the pages from Ken. They're going to go say, oh, let me see what Ken has posted. Pow! It runs the script on their computer. And then my script is running on their computer, and who knows what it might do. You again go out and get information, capture information from your site, send it someplace else, and all sorts of other nasty things. If you're an attacker, one of the nice things about this is you can attack many people at once. You can put the evil information out on the server then displays it to a whole sorts of people, all of whom's the browser executes it and sends information to you, or does whatever it is, evil thing that you want on your do. And there are various viruses and worms that propagate this kind of information. There are DOM is domain object model based attacks. They're based on the local server. They are going to go out and change the website, or excuse me, change the web page. So you can change what appears on the screen. And that can be persistent or non-persistent. The example I showed you was that. All right. It's a serious problem. It's not going away. You can go into the options for your browser, be it Chrome or Edge, and turn off JavaScript. That will keep the problem from happening, but almost every web page these days uses JavaScript. Almost nothing will work after that, so that's not a really good answer. You have to write web pages that don't let this problem occur. Basically, don't put user data into a place where it'll get executed. There's another problem that we have with websites. That's parameter tamping. When you type in some information, it sends it off to the server as part of the URL, where its name equals value. Some sites put information in there that they shouldn't, because somebody might change that. And they can change it to help them out and not help the server. You can look at the information with a network proxy or an HTTP proxy. The network proxy is a piece of hardware, or more often software, on your computer. There are many software, I'll talk about that in a minute. There are software, and everything that goes from your browser goes through that intermediate software. It then sends it off to the web server, which comes back, and the web server goes to the proxy, and the proxy sends it in. The proxy can inspect it. They can check for problems. It's particularly nice, though, when you're working in a Comp 422 or Comp 620 class is you can look at the data that's going across, you can inspect what did it send, and you can change it. There are a couple of proxies out there that are very easy to use, more or less. There's the OWASP. We'll talk more about OWASP shortly. They have a Z attack proxy or ZAP. It's free, and you can get it from here. Another one that I happen to like better is the Burp Suite one from Portswigger. You can go down there. There's the Community Edition and the Professional Edition. We're going to be using HTTP proxies in the near future, so you might want to get this. You can get the Community Edition, or if you really like it, you can pay $449 and get the Professional Edition. The Community Edition is free. Choose what you like. All right, let's take a look at this web page. Here we are selling, I guess it's textbooks. We have a textbook and we have URL. The user has typed in quantity they want and they clicked on the add this to their cart. So it's going to send off a request back to the server, send book ID, give the book ID, which represents this book that you might, if you have really clear eyes, you can notice that this is the last 4 characters of the ISBN, which they put there. Quantity 1, price, no, they're given the price. Well, that's nice, except the price is there. If you capture that with a proxy server, or go up and change it after it's been sent, you can change the price. You don't like the price $59.95, you can change it to $5.95. You can change it to 1 cent. And then if the server is foolish enough to be using that as a price, you can buy it for whatever price you specify. I recommend making it a smaller number instead of a larger number. And therefore, you managed to get away buying something on this website for much less than the company expected you to pay. Let's see if people understand this. Okay, there we are. Yes. Got it. Oh, C is the most popular answer. Oh, both online and here. You can see the answer. Oh, we have one person doing everything and a whole bunch of people doing the correct answer. C. Yes, as I mentioned, the information can be viewed and edited in a proxy. Typically, it's also in ASCII format, it's character format. You can look at it, you can edit it, change it as you like. So what do you do about this? First of all, don't trust user input. And in this case, the application should not be keeping the information on the web page that goes down to the user. They should keep it only on the server. The server knows what books it has and should keep the price on the server. So not to get the price from the user, who will set the price where they want to. Sometimes websites will release a little bit more information than they should. So you want to go out and you say you want to look at some orders, look at a list of all the orders that you've made for the books. So we have a list of books, and we have an order number that you can click on and do something. But the order number, 2456, 2457, I wonder what 2458 is, or what's 3802. Well, if the system is going to send that order number, you click on it, the order number, put the number there, you might just guess what the next number will be and get somebody else's order and be able to change somebody else's order. that's probably not what the company wants. Sometimes you don't even have to get, you go out there and say the solutions are for homework assignment 3 or HW3 solutions. We have another homework. Where might you first look for homework for the next assignment, homework 4? Well, if you're an idiot, you go out there and you look at HW4 solutions.pdf, which might be posted before the answers are due. They aren't, but so there's a way to fix that. First of all, don't use sequential numbers. Use long random numbers. All right. Yes, for both of these cases, for the hiding the information in here, instead of using simple names, particularly if the names are accessed through a link that you provide on the web page, generate large random names. They don't have to be too long, but you go out with your random number generator, generate a hexadecimal, generate a 32-bit number, convert it to hexadecimal, use that as the web page number. It doesn't make any sense to humans. And if it was randomly generated or generated through a random number generator, it's the next random number in the random number generator that you're using. It looks random to anybody else, but they can't guess what the next number is going to be. So you don't know what it's going to be. You can't make that. It'll be the next one. You have to watch out for hidden parameters. Some websites have hidden. These are parameters that are sent when you press enter, but they don't appear on the screen. Typically, the input is an input box on the screen. You press enter, it takes the data from that box, puts it on the parameter list that's sent off to the server. There are other parameters that might be sent that aren't on the screen. Those are hidden parameters. They can make writing the web page a little bit easier. In this case, we might have ID equals admin, and it will send back ID equals admin on that. Well, gee, isn't that convenient? Particularly if you say something like ID equals user, you might just change it to a couple other names and see what name gets you some excitement. Again, don't give information to the users that you don't want them. Now, HTML has the information that's to be displayed, along with all sorts of formatting information about how it's being, and references to cascading style sheets about how it should be displayed. And then you've got your JavaScript. It's a program. And so good programmers will put comments in their programs. The comments sometimes have too much information. In this case, I'm showing when you're testing it with password bad choice to test. Oh, so the password bad test is magical. Use ID tester with password bad test. Oh, you can get it to the test system. That's interesting. There are tools that will pull out all the comments from your HTML page. So you write it with comments so colleagues and other people in your organization, when they look at the web page, can say, ah, yes, I know what this guy was doing when he wrote it. This is what it means. This is why this is this way. But that's not what's sent to users. Instead, you strip out all the comments when you send it to users so they don't see anything. Usually they strip out comments, take out extra spaces, compress it to make it small and hard to read. Another interesting thing that problem I had on my website is if you don't specify a default page. Default page is if you go comp 422 comp 620.h.online /encrypted, nothing. That's a directory in my website. That's where all your stuff was. If you didn't specify a file name, just directory, said, oh, you want to know what's out of that. So it would send you a list of the directory, which is not what I had in mind. That was a problem. And somebody noticed that, oh, I can find out all the files that are out there. Yes, you can, but you can't anymore because I put out a default.html or an index.html. Those two are the magic names. Those are the defaults. If you go to a website or to a directory in a website that does not, and you didn't specify a file name, it will use one of these if they exist. Typically in your web server, by the way, you specify which one to look for. So there's an index, it'll go out and get the index. So if you omit that, then sometimes users can see information in that directory. You can also set a parameter in your web server software, whether you ever show a list of the file elements or not. and it's wise to turn that option off. Oh, another poll. Let's try this one. Oh. Okay, almost everybody thinks it's D, which is good because it is D. Everybody picked D. One person got confused. Yes, all of them. You can store, again, put the important information that you don't want the user to change on the server. Don't put it someplace where the user can change it. Avoid using sequential numbers. Again, random numbers, a nearly easy feature is take a random number generator. Random number generators aren't really random, they're just sequential. The results look random, but they aren't. Particularly if you only strip out like the middle bits of it, it looks really random. So you have a sequential number that you're using, you run it through the random number generator, comes out with a number, that's what you show to the user. You name things that. And again, random page names work really well. So users can't guess what they're supposed to be. There is an organization that I've mentioned several times before, the Open Web Application Security Project, OWASP. OWASP has a lot of information out there about websites and web security. And it's a good site to look at. It's owasp.org. Lots of information about web vulnerabilities and what to do about them. I want to point out there are 10 top threats. They always publish a list. This is the 2021. They didn't apparently do it in 2022. I didn't see one for 20. This is the latest one I can find. But these are the top 10 big threats that they have measured. You can go out and read how they measure them. These are the broken access control. That's not properly authorizing users, allowing people to get it. Cryptographic failures. It's not necessarily meaning that AES didn't work, but they're using it improperly. And that causes a lot of problems. Injection. We've been talking about injection. That's used for SQL injection, cross-site scripting, cross-site request forgery. All these involve bad inputs, using information from the user. Insecure design, that's just building it poorly in the first place. Security misconfiguration, where you fail to configure what's supposed to be safe and what's supposed to be secure. If you don't protect it, then it's not protected. If you don't do anything to protect it, then yeah, made a mistake. Outdated components, particularly if you're using open source software, sometimes some of the open source components have been updated. You need to go out and get the newer versions of the open source software so you're running the new versions. Some of the old versions may have vulnerabilities that everybody knows, including all the bad guys. Authentication failures, that's a broad range of making mistakes when people are logging on, that you're accepting bad input. Integrity failures, accepting serialized objects of validation. That's insufficient logging and monitoring. Yes, you should monitor and log. When people go out and get information, it should be logged. There's real simple logging on your web server and many other parts of your operating system. Turn them on. They don't have a lot of overhead. That way you can go back and see all the requests that are made. So if you find that something funny is going on, you can go back and say, well, where did this come from? Who made this request? And then the server-side request forgery, which we'll talk about later on. So lots of problems. These are the top 10. There's more than 10 problems, but these are the big ones. They have their guidelines, cheat sheets. It's a list of things to do on a website. Let's go out here, look at these things, and fix that. Now, if you go to their cheat sheet, it gives you a list of items that you should check on your website. Are you doing this? Are you doing that? If you go to the end of the bottom of the cheat sheet and you've corrected all those things, your site should be relatively safe. Oh, and it says here we're going to check. That's after this question. Yeah, another question. All right. C is a very popular answer. All the above. Yes, it is all the above. SQL, I think I just said that a little while ago. SQL injection, cross-site scripting, both involve taking user data and putting it into something that will be interpreted, and that causes problems. Not just these things, but I can tell you in other places it does cause problems. Okay, here's what OWASP says to prevent cross-site scripting and other problems. Rule 0. They're computer people that started Rule 0, of course. Never insert untrusted data anywhere on the web page except as indicated in the following rules. Don't put it in HTML. Don't put it in JavaScript. Don't put it in cross-site scripting. Don't put it in Azure. I don't know where else you might put it if you don't put it there, but don't put it there. Rule 1. Encode information that's going in. In other words, use HTML encoding. What's HTML encoding? Well, there's many ways to encode some of the special characters. Instead of just putting a bracket, you can put ampersand LT semicolon. And that is transmitted across the web, and that means a less than sign. Obviously, GT is greater than, there's quotes, there's ampersands. A single quote is an apostrophe and apostrophe. Also, you can use the hexadecimal values of the ASCII numerical value for that character. So here is ampersand pound hash X27. That means this represents the 27th ASCII character, 27th hexadecimal. You can convert that. If you can convert that to decimal, then you should have no problem with the base number conversion quiz. Okay. Now, there are a bunch of tags that may or may not be safe. There are some tags such as bold, italics, underline, emphasizes, strong, are fine. They don't cause any problems. Other tags, script, object, embed, link, you want to avoid putting those in. So it may be necessary, it may be desired, if your user is typing in information that they're going to display, you might want to allow them to bold terms, change things so they can write with a little bit more style. But you don't want them to do things that are dangerous. So there are tools that will filter these out. Except for the alphanumeric characters, everything should be encoded in the hexadecimal format. Don't use some of the scripts, or actually these are HTML tags, and they're only safe. So all these are tags you can use in HTML. Those are only safe, but they have to be used inside quotes. Nothing there does anything particularly dangerous. Input encoding. When you get input, you can encode it, and there are functions in HTML and JavaScript to do so. So you can give it something, and it returns it, it will code it for you. The encode URI, Universal Resource Identifier, turns a coded version, so it takes out all these characters. There's a reason why I have the first 5 characters, well, 6 characters in red, because sometimes there are some tools that will change those and others that don't change those. Fortunately, I can't remember what it is. But anyway, the whole purpose of encode is it will take regular text and change. If somebody put a bracket in there, it changes it to ampersand encoded. And you can also do it back. And you should encode things before you put them in the URL. Another problem is uncrusted data JavaScript. Well, this is a big problem. And this is always encode things before you show it. Watch out for dynamically generated HTML. There's JSON is a very popular way of sending information from the client to the server or from the server to the client. Often on these web pages where you might type in something, it sends a request off to the server and the server sends back a response. The response, particularly if it's a bunch of data, will probably be in a JSON format. JSON is pretty simple. We're not going to discuss that at length here, but it's got brackets and parentheses and quotes and colons and to give us basically a variable name, colon value, it's all in quotes, but it's very useful for sending information back and forth. You can send it back, and it should be used to encrypt or code things instead of just sending it as text. And of course, encrypting things. CSS and code. CSS is CSS is cascading style sheets. You got a lot of acronyms here. Cross-site scripting XSS is much different than cascading style sheets. You have to watch out for changing the cascading style sheets. Also, bad information. Not only can errors be located in the text that users, but some people share cascading style sheets, CSS. And there may be bad information there when you use that. Watch out for that. And again, once again, if you're creating a link, watch out for user input. Code that properly. You can say, is valid URL, and you can give it that. If it's not valid, don't use it. And of course, watch out for sending data to someplace else. This is cross-site request forgery, which we'll talk about next week. But you go out there and ask for information. The image, this is your image. IMG says, this is where you want to put a picture. I want to put an image in the screen. And I want to go out to this other website based on what the user entered. You're not allowed to send requests for information to a different website, but you can get images from anywhere. So you might ask for a file with a file name that isn't at all existing on the server. They don't care. They're going to send you back the same file. But this evil server is waiting for some name. You might go out and get the user's cookies information, store that as the name of a file, go out and request, and then return whatever you want to as the name of a file. But you've asked that, and now the server, the evil.com server, knows the information that you didn't want to share. So even though the standard XML HTTP request, which is how you send information to your server, will only send it to your server. It can be broken by going out and saying, I want to get this picture from someplace else, even though you're not getting the picture. You're making a request with information in it. And of course, that secret stuff can be rather long. All right, that's enough for today. We'll talk more about this next week. Remember, by tomorrow at noon, if you haven't got a grade of 85 or better, you can go out there and do the test. Now, let me explain this quiz once more. Quiz is going to ask you 20 questions. And then we'll tell you a percent right. The percent right is nice, but what's really important is the score. The score depends on how long it took you to do this. So if you're an undergrad taking Comp 422, and you have to be taking 420. If you're an undergrad taking 620, then you end up as the master. You look like a master's student. You're undergrad taking 422. You have 90 seconds to do it. So let's say you go out there and you get all the questions right, but it took you 1 minute and 40 seconds to do it. That's 100 seconds. That's 10 seconds over the limit. So instead of getting 100, you're going to get a score of 90 because you're going to subtract that 10 seconds. If you are a post-baccalaureate certificate student. That's post-baccalaureate certificate, student, not the students who are getting a BS in computer science with a cybersecurity emphasis. Nope, they're still 120 or these are the students who in the program, they've already got an undergraduate degree that going out to get the cybersecurity certificate. They get to 180 degrees. And otherwise you get 120 seconds. And that's your limit. So once you figure out what your limit is, it's seconds over the limit. So you have to do it fast. If you're going to get a good score, you got to do it faster than your limit. If you are a certificate student, you got to do it faster than 3 minutes. If you're slower than that, you're going to start losing points. An awful lot of students seem to forget the time thing. No, you have to do it fast. Okay, here's the schedule coming up. That's today. Next Monday, do not come to this class or any other class on Monday. It's fall break. We'll have a class on Wednesday. Next week, we'll talk about some of the things I mentioned today, cross-site scripting, more click-jacking, and other evil things you can do. Talk more about those the Monday after that. Getting ready for the exam, which is in 2 weeks from today. We'll have the second exam, 2 weeks from today. All that, TAs and I will then grade that over the weekend, give it back to you before that Monday, which is good because that's the last class day before the last day to drop. So if you get really lost and you think it's time to bail out, you have to bail out before the 23rd of October. Okay, that's it. If there's any questions, that's the end for today.
I got a question. I'm sorry.
Yes, far away.
Yeah. It's about the conversion quiz. So for the percentage that we can still get correct, the maximum is 85, right?
That's right.
All right, got you.
I'm just going to and I thought about how to apply that. Should I scale it? Should I subtract 15 points from all your scale? I decided just to cap it. So if you get a score of over 85, I'll give you 85. So if you get 100, you're only going to get 85. You get 86, you get 85. If you get 84, you get 84.
Got you. All right.
If you've done it earlier, you got full score. Any other questions?
Nope, that'd be all. Thank you.
All right. See you next time. If you have questions, of course, email me. Thanks.